The Math Center presents Similar Figures. In this presentation, we'll discuss what similar figures are, how we can work with similar figures, and we'll work on some example problems that involve similar figures. So what are similar figures? Similar figures are figures that have the same shape but are different sizes. More specifically, we would say that figures are similar when their corresponding angles are congruent and their corresponding sides are proportional. So how can we work with similar figures? Well, as we just mentioned, in similar figures, corresponding sides will be proportional to each other. What this means is that if you have an unknown side, you can find its length by setting up a proportion and cross-multiplying. In this presentation, all proportions will be set up using the following format. Side 1 of the first figure over side 2 of the first figure equals corresponding side 1 of the second figure over corresponding side 2 of the second figure. Now let's look at an example. We have two similar triangles. The larger one has side lengths of 9 and 12. While the smaller one has one side length of 3 and one of the sides is unknown. We start by setting up a proportion. Since these figures are similar, we know that the ratio of the sides in the smaller triangle will equal to the ratio of the sides of the larger one. We take the two sides from the small triangle, 3 over x, and we set them equal to the corresponding sides of the bigger triangle, 9 over 12. Now we will cross multiply, and this gives us 9 times x equals 3 times 12. Performing multiplication, we have 9x equals 36. And by dividing both sides by 9, we end up with x equals 4. So the unknown side is equal to 4. Now let's look at another example. This time, we take the two sides of the bigger triangle, 12 over 20, and set them equal to the corresponding sides of the smaller triangle, x over 5. The next step is to cross multiply. This gives us 20x equals 12 times 5. Performing multiplication, we end up with 20x equals 60. And dividing both sides by 20, we have x equals 3. The unknown side is equal to 3. The process is the same with rectangles. What we do is we take the two sides of the smaller rectangle, x over 4, and set those equal to the corresponding sides of the bigger rectangle, 17 over 10. The next step is to cross multiply, which gives us 10x equals 17 times 4. Performing multiplication, we have 10x equals 68. And dividing both sides by 10, that gives us x equals 6.8. Once again, the process will be the same with these hexagons. Start out with a proportion. Take the two sides from the bigger hexagon, 11 over 5.5, and set those equal to the corresponding sides in the smaller hexagon, 5 over x. Next, cross multiply, and this gives us 11x equals 5 times 5.5. Performing multiplication, we now have 11x equals 27.5. And dividing both sides by 11 gives us 2.5. So the unknown side is equal to 2.5. Let's look at an example of a word problem. A man, measuring 6 feet tall, casts a 10-foot shadow. At the same time of the day, a tree has a shadow that is 12 feet long. How tall is the tree? If you'll take a look at the picture, you can see that the man and his shadow create a triangle. The tree and its shadow also create a triangle, and these are similar triangles. So this is a similar figures problem. We started with the proportion just as we did on the previous examples. First, we'll look at the triangle associated with the tree. That will give us x over 12. We'll set that equal to the corresponding sides of the triangle associated with the man. That gives us 6 over 10. By cross-multiplying, we now have 10x equals 6 times 12. Performing multiplication, we have 10x equals 72. Dividing both sides by 10 gives us x equals 7.2 feet. The height of the tree is 7.2 feet. Thank you for watching this presentation on similar figures.